Welcome to today's explainer. We are heading millions of miles away right now to look at a recent, honestly mind-bending discovery on the Red Planet. It's a discovery that essentially turns NASA's Perseverance rover into an interplanetary detective, roaming the dusty landscape of Mars, just hunting for clues to the planet's ancient past. And, well, the latest clue it found? It completely shocked the scientific community. So it all starts with a pretty simple but definitely provocative question. What happens when you shoot a laser at an ordinary Martian rock? Think about it. You've got this desolate, super dusty environment, a seemingly plain, boring gray rock, and this high-tech rover literally zapping it with a highly focused beam of light. You'd probably expect some dust to fly, right? Maybe a tiny scorch mark? But what the rover's instruments actually detected, hidden deep inside that rock? No way. It changes our entire perspective on the geological history of Mars. Okay, let's dive into this. Section 1. A laser on Mars. So our detective in this story is NASA's Perseverance rover, and it's been steadily exploring this totally fascinating region of Mars known as Jezero Crater. Part of Perseverance's daily routine, its day job, involves investigating the local landscape to see exactly what it's made of. And to do this, the rover is equipped with an incredibly advanced piece of technology called the SuperCam. This instrument literally fires a laser at Martian rocks to vaporize a tiny portion of them, which then allows the rover to analyze the chemical makeup of the gas that comes off. So picture this. The rover rolls up to this rock, a rock that to anyone looking just looks completely standard and unremarkable, and it fires that SuperCam laser. It was supposed to be just a routine analysis, but the data that beamed all the way back to Earth was, well, anything but routine. Section 2, the unexpected gemstone discovery. Chromium-bearing corundum. I know, it sounds incredibly dense and academic, but let's break down why this is so absolutely exciting. Corundum, down here on Earth, is actually the mineral base for precious gemstones. We're talking rubies and sapphires. And the rover's laser detected unusually high amounts of this exact gemstone-associated mineral right there, inside the Martian rock. Specifically, the rover was examining what scientists call plagioclase-rich float rocks sitting right on the rim of the Jezero Crater. Finding these minerals in this specific location? Completely unpredicted. It's kind of like, it's like opening a dusty old cardboard box in your attic and finding it lined with velvet and jewels. It completely upended what researchers ever expected to find in this part of the crater. This shockwave through the scientific community is best captured by Anne Olilla. She's a geochemist at the Los Alamos National Laboratory who actually led the team analyzing this data. She wrote that, quote, "Very unexpectedly, SuperCam's analysis found to exhibit clear signatures of chromium-bearing corundum." Now, in the world of highly measured, peer-reviewed science, a phrase like very unexpectedly is basically the equivalent of a scientist jumping out of their chair. They simply did not anticipate these complex minerals just sitting right there on the crater rim. Section 3. How did they form? So how do you get gemstone-linked minerals inside a seemingly boring rock? Well, it comes down to a really dynamic three-step geological timeline. Step 1. Millions or honestly, possibly even billions of years ago, cracks formed in the Martian rock. Step 2 is really where the magic happens. Ancient hot water moved maybe violently, maybe steadily, but it flowed right through those very cracks. And step 3, as that hot water interacted with the rock, it left behind deposits, creating these crystals and gemstone-like minerals. Now, what's really interesting about this whole process is that we know this because on Earth, similar hydrothermal conditions, hot water flowing through rock, help create crystals and gemstones literally all the time. So this rock is, for all intents and purposes, a fossilized record of ancient hot flowing water. Section 4. Water, volcanoes, and life. Okay, here is exactly what you should take away from this explainer. First off, the presence of this chromium-bearing corundum is basically a massive neon sign pointing to subsurface water movement. It proves, without a doubt, that water played a major active role in shaping the Martian landscape. Second, it gives us some really deep clues about the history of volcanic activity on the planet. Because think about it, you need serious geological heat to create those hot water flows in the first place. Third, it tells us that Mars had far more complex ancient environments and geological processes than scientists previously believed. It definitely wasn't just a dead, static rock. And finally, and this is absolutely the holy grail of Martian exploration, these complex, watery, warm environments strongly hint at the planet's suitability for past microbial life. Where there's hot, flowing water and rich mineral chemistry, there is for sure the potential for life as we know it. Section 5. Unlocking Martian secrets. Now, it is really important to note that these paradigm-shifting revelations, they're grounded in rigorous, peer-reviewed science. The detailed findings of this incredible discovery have been officially published in the journal Geophysical Research Letters, and that really cements the immense value of the rover's daily work. Literally every single time it fires that laser, it has the potential to rewrite planetary science textbooks. But here's the coolest part. Perseverance isn't just looking and analyzing from afar. It is actively collecting. The rover is painstakingly gathering samples of these rocks, packaging them up, and just leaving them on the Martian surface. Why? Because NASA and its international partners are actually planning future missions to retrieve these samples and physically return them to Earth. Just imagine having these exact pieces of plagioclase-rich rock, complete with their ancient hot water gemstone signatures, sitting in the most advanced laboratories on our planet for deep, hands-on study. The secrets they could reveal about the long geological history of Mars are, well, they're practically limitless. Which leaves us with one final, pretty thrilling thought. If a seemingly ordinary rock on the rim of a crater holds unexpected gemstone secrets and vital clues to a hot, watery past, what else is hiding in the Martian dirt, just waiting to be returned to Earth? The red planet still has so much left to teach us, and millions of miles away right now, a robotic detective is working tirelessly to uncover it. Thank you so much for joining me for this explainer. Keep wondering, keep learning, and I'll catch you next time.